Okay, well, I might be live. I'm gonna give it a few moments here. Okay. Well, I think I'm just gonna get right into it. So, Blazer here from Split Logic Keyboards. Going to be building a ZodiarkPi kit on stream today. Going to be soldering this fully together, getting it hopefully working, kind of going over firmware, building it, and just hopefully making a fully functional keyboard today. So let me just get to my desktop here and start working on this. All right, grab you real quick. All right, sorry if there's some wobbliness going on here. And let me just flip that back. All right, so I'm just going to get right into this here. Let me start some music up. Checking a few things here. Yeah, Tacklop, this is being recorded as well, and hopefully I'll be able to put it together in like chapters so that people can just watch it on YouTube. So yeah, this will definitely be recorded. You'll also have the VOD as well. Ignore the church bells going off in the background. It's just turning noon here in St. Louis. Okay. All right, so hopefully everything's looking good here. I might hear some desk noise as I readjust my microphone here. Gonna be putting away my keyboard here. You'll probably hear that as well. But first and foremost, I kind of want to go over what comes in the kit for the ZodiarkPi. So first and foremost, you will get all of the large parts here. So this is going to consist of your diodes, your hotswap sockets, your per-key LEDs, and your Underglow LEDs. So that should have all of those. I make sure to include at least a couple of each larger component so that if something goes wrong during soldering or something happens to the if you lose like a diode while you're opening up the strip, you've got a couple left in there to help you finish up your build without me having to mail you new parts, which is no fun for anybody. So move those out of the way. Then inside that bag, you'll typically find the smaller bag of the smaller parts. This is going to consist of your Lil-CC C2C boards for the interconnect between the two ZodiarkPis, your two reset tack buttons, caps for smoothing the current to the LEDs, and then your VIK connectors, VIK or circuit, depending on what you use, as well as your 10K resistors. The 10K resistors are used to tell each half if they're left or right through the use of either pull-up or pull-down resistors. On the board as well, you will see that I do have spots for the 4.7K I2C. Those are optional. If you do end up using like an older style OLED or some sort of I2C peripheral, typically that's going to have its own pull-up resistors, so you wouldn't really have to worry about that. So now let's go over what you need to bring to the party. First and foremost, you will need some sort of Pi Pico or Pi Pico equivalent. I typically like to use these WaveShare RP2040 Plus Picos. These work perfectly. You don't really have to make any kind of modifications to get these to work correctly. They just compile and they're ready to go. So next up, you will need some sort of encoder. You can either use your standard EC11 with click button. These are pretty easy to get a hold of here. one for each side. You also have the option of using the Alps dual axis encoder. So you have one axis up top, one axis at the bottom. Still get a clicky button as well here. As you can see, it's pretty similar to an EC11, except for you have an extra 3-pin on the far side there. So you've got your 2 and then another 3. Oop. Some dust blowing in from outside. Or you have the option of using the Panasonic roller encoder. This one has a little bit different of a footprint. It's a little smaller, but it's also a really good option as well. For the encoders, you will need some sort of knobs for those. For the regular EC11s, I do like using guitar knobs. They're pretty cheap on either AliExpress or Amazon, depending where you're at, and they look great. So on top of that, if you look in the Zodiark case repo for the dual axis encoder, I do have a 3D printable top for those. They just use M3 grub. Actually, I think it's either an M3 or an M2. I'll have to double check. Grub screw to go onto these. So they just kind of go in over this. Actually, this one I think was printed a little too small. Nope, that's perfect. So that one goes there, that one goes there, and you use the screws to, oh, that's because I put this thing on upside down. Oops. There we go, that's better. Use the grub screws to kind of hold it onto there, and you'll just want to make sure to kind of tune the bottom one so that the top one has enough clearance to click. So there we go. I'm just going to be using EC11s for the purpose of the build. Putting on the other two is not much different at all. So next up, you'll want your extras. The main selling point of the ZodiarkPi is the fact that it does have built-in breakouts for SPI for screens, either the round GC style screen or the large Waveshare 2-inch screen over here. I typically like to use hotswap sockets. I will link these in the Discord, and I do have a screen kind of pre-cut for these as well. So the one I'll be using today is the 2-inch LCD module from Waveshare. That I just soldered on and trimmed this, and that will mate up with this guy right here, no problem. And just as a heads up, if you do get the hot swap sockets, you'll notice it's only 7 instead of 8 here. The backlight pin is not actually connected to anything. So if you were going to use the Waveshare, you would just make sure it's covering VCC to reset, and don't worry about the backlight. Put this back over here. For the other side, you have quite a few other options. You do have the option for a circuit. If you look on the repo, I also have a holder for that that mounts up to the mounting points for the screen over here, or on the other side as well. This is nice because it does have the notch for the curved overlay, and that kind of fits in nice and snug, so that isn't going anywhere. You also have the option of mini VIK modules, thanks to Finger Punch. The one I have here as an option is the Trackball with the per 56 roller encoder over here. I'm just going to disassemble this real quick. So this has a optical sensor that you solder in. I did have to put in a little bit of a 3D printed spacer here to get it to actually pick up the ball itself. But the ball sits in a 3D printed housing with nylon bearings. I want to try out some other ones because there are some like really nice like pre-made bearings in like a cylinder that you press in. That's going to need to be put together through I think a different type of module here, but for today's example we'll be using this as well, or the circuit. I really haven't made up my mind yet, but I think I might do both because there are some changes you do have to make to the board itself. There are a few jumpers you have to hit to enable the VIK, and just know that if you do enable the VIK enabled jumpers, do not plug a circuit directly into the board because there's going to be 5 volts heading to a couple pins, and I wouldn't want anybody to burn out a nice fancy circuit touchpad. Okay. And last but not least, you'll definitely need either a USB-C or a micro cable, depending on which you choose, either the the RP2040 Plus or some sort of equivalent, or the Pico that has a micro USB port. Just take notice that if you do use the any kind of other RP2040 Pico pin compatible microcontroller, that it does need the pad mountable pads on it. If it's just holes, it will not go on. I do have this designed so that it's just surface mount to kind of simplify the process. Typically these, I would definitely recommend getting a magnet cable to prevent any kind of damage to the actual port on the MCU. But yeah, definitely your choice on that one. And last but not least, you'll just need a standard USB-C to USB-C cable to connect the two halves. So, pretty much covers that. For some miscellaneous, I do have some nylon standoffs for the screen and the setup here. And also I did forget to mention, for the VIK module, I do have a 3D printed adapter plate that this goes on top of that has cutoffs and allows you to mount 4 screws to standoffs coming off of where the screen would normally mount, and then you can mount the VIK module on top of it. So that's also in the Zodiark case repo on the Ailblazer GitHub. So just go ahead and check that out if you wanted to get STL files to 3D print that. All right, time to start pulling apart some reels here. The build is separated into several steps. First and foremost, definitely make sure you've got everything you need to start the build. I'm just going to count out a few things here. For the diodes, you will have typically two strips of diodes. This one's a little shorter because it was the end of the run there. You're going to have 2 strips of the per key legged LEDs. You're going to have 2 or 1 long strip, depending on how I cut it that day, of the bottom-mounted under-firing LEDs. And then typically for each, you'll have 7 total of the hot swap sockets. Now, for today's build, I'm going to do something a little different here. Normally, you would do all MX or all Choc. Today, I'm going to be doing a mixture. I'm going to be setting it up so that the main alphanumeric area is all MX, and then the bottom row is Choc, to kind of go for that staggered setup there. I did also design this top plate for the plate case. I'll be putting this on the GitHub tonight once I do a couple more updates. So I'll be doing the bottom row in Choc hot swaps and the thumb cluster in Choc and the rest in MX. So, all right, I think it's about time that we start the soldering iron up here. So recommended temperatures for everything, I'm just going to let you know that up ahead of time, is typically when you do this, you'll want to make sure that for the diodes, I typically keep it in the high 300s to just below 400 range. This allows you to get good flow and allows you to kind of easily handle everything that you need to handle. And, you know, you're not really going to have to worry about burning out diodes or hot swap sockets. Or the pads to like your Pi Pico. But when it comes to the LEDs, the RGBs, you definitely want to get that down a bit. You want to get down to probably under 300, depending on how skilled you are at soldering. The more time you spend holding it to a leg or a pad, the more chance you have of destroying the LED, which at that point, you really don't know when you destroyed an LED until you finish the build and you've plugged in, and that's no fun to troubleshoot. But I digress. So if you're newer to soldering, the lower the better, so you can kind of mess around a bit more. If you are a bit more skilled and you want it to go a bit faster, you can typically go a little bit over 300. I sometimes personally do about 320 just because I'm pretty quick about hitting the legs and moving on so that it's not building up enough heat to kill an LED. So, but yeah, let's move this into steps. First thing we'll be doing is the diodes, then moving on to the hot swap sockets, then the LEDs. At the end, I'll wrap up by putting in the caps, let's see here, the caps, and then let's see, then the resistor, and then at that point we'll be working on installing the VIK. Let's see here, the VIK connector, which is right over here. So for the VIK connector, I definitely recommend having a couple extra supplies. First and foremost is going to be some sort of solder wick. I prefer this NTE fine, no clean wick. This does a good job if you chop off a small piece at removing excess solder and clearing bridges that you may have. And then for testing, to make sure you don't have any shorts, I do have a breakout board for a PC connector, and then I would use my continuity checker. Got a Flying Tools one over here. It's covered in wires. To check continuity between each pin and making sure that each pin only lights up on one thing. So that would give you an idea if you had any kind of shorts or anything. So I'll be doing that as well on stream, so you'll see what I'm doing here. In the future, I do have in development a easy VIK board. I've been working with Finger Punch to kind of get that going. So that we'll have a Lil-CC style surface mount board that already has the VIK connector on it. And at that point, you're only soldering to large, 2.54 spaced pads. So it makes it a lot easier for the less soldering experienced people amongst us. So I think I've waxed poetic enough about this. For today, the other stuff that I'm typically going to be using is I do like the full lead Kester solder, and then I have an SRA flux pen for reworking. The flux helps out a lot for the VIK connector, as well as the solder wick. And on top of that, typically I'll have a small brush and some 99% alcohol to clean all this up. If you're in Europe, I don't think 99% IP isopropyl alcohol is available to you, but I think there's other alternatives out there, such as like dedicated flux cleaners and things of that nature. All right, so let me clear this off and get these put together here. Just going to start off with the diodes. So first step when you are starting off your build is you'll typically just want to tin your right diode pad. So that's what I'm going to start for all of these here. I'm going to be doing both boards. Let me just get this all kind of prepped here and get you zoomed in. So ignore the wobbliness here and some of the wind noise. I've got the window open to help with air quality here. So let me just adjust this. Okay, perfect. All right, so just gonna get the diodes open here. Just need to grab a pair of tweezers. If I can remember where I put my good tweezers. Now these are good enough. Should leave it level. I cleaned off my desk a little too hard and just kind of threw everything into a drawer here, so I'm paying for that right now. All right, just gonna open these up real quick. I've tried to choose diodes that are a bit easier to see the polarity line on. Over time, I've definitely had some that are like nearly impossible to see with the naked eye. So I've made some choices here on diodes to make sure that they are usable. And actually, the ones that I just pulled up are kind of hard to see, but hopefully the camera can help out with that a little bit. All right, there's one strip. Where's the other strip? Okay, strips are prepped. And I'm just going to get a long thing of solder here. For soldering irons, typically I use a Pinsel. I do have a Pinsel version 2 here with a rounded tip, and I do have a Pinsel version 1 with more of a chisel style tip. Typically I like to use the chisel style tips more for the LEDs because it allows me to cover an entire pad and kind of get everything to flow in. So, but for most of the other stuff I like to use the rounded, just regular pointed tip. All right, here we go. So I'm going to pin the right side of all of these to get a pad ready with some solder so that we can then place our diodes. So I'm just going to start that up right now. Soldering station in a little more. Actually just purchased a air quality monitor from Govee Life the other day. It was showing 0, so I thought it was broke, and then I started soldering and it went up to like 99999 because they didn't have any windows open or anything or any filter going. But I have a fan going, window open, and I've got my fake Pico 3D printed carbon filter going as well. You might hear that in the background. And as you can see here, I've got the rows of them 2, 2, 2, 2, 2, and then skip one row, and then 2, 2, 2, 2, 2, and then the bottom's just a single row of the diodes. And then there's a couple hidden over on the right for the encoder and other things. So just keep an eye out for these. And then, yeah, right here next to the circuit SC. There we go. And then the bottom. And I got the 1 here and then the 2 right here. All right, that's one down. Why am I getting Facebook messages from Big Tree Tech? I've already spent enough money on you guys. Don't bother.
Just excited.
Just realized on my giant scrap heap self-built Ender extender, my 400 by 400 by 500 Ender 3 remake, my second Z motor was just decoupled for who knows how long. I was printing on it, and I did a Z-tilt to adjust it so that the gantry would be level with the bed, and it just wouldn't adjust. It just kept on trying, and it stayed the same distance between the left and right side of the bed on the gantry. And then I realized that the right side was not locking, it was just spinning. So kind of explains why I was having some Z-banding problems in some of my prints. I fixed that screw up, and now it's working perfectly. For a giant, heavy, unstable monster of a printer, it actually puts out some pretty decent prints. Yeah, the step for the PCB is available in the case repo as well. It should be under the design step folder underneath ZodiarkPi. Should be up to date and ready to go. I think I actually have one with pads and traces on it. I'll have to upload that one as well. I think I only gave that to Chewy Dies. All right, cool. So I think we've tinned all the pads here. So now it's time to place your diodes. Sorry if that was loud. All right. So at this point, I'm just going to start grabbing some diodes here. Finding the line on them. These are actually a little hard to see. Yeah, those are not the greatest ones I've ever used. Sometimes if you tilt them, it's a little easier to see. So just kind of place them next to the pad that you're going to be putting them on. Just putting the soldering iron up to them and then sliding them in, making sure there's enough room so you can see the other pad. And then wait for that to solidify, give it a little jiggle, make sure it's on there, and boom, got a diode on. A little quicker than doing the bending and snipping of through-hole diodes, in my opinion. It just takes a little bit more finesse. Oh, no problem, Jenrid. It was definitely something I was trying to make for that dactyl kit that I gave you, and I just never really finished it. And at this point, if I was going to do something like that, it'd probably be like a bastard KB, like Skelly or something like that. I think those are really cool. That guy does great work, especially with those flex PCBs. Got to get a bit more confident in my designing to be able to try to do some flex PCBs in the future. Over here wrestling with the diode, trying to get it to the right polarity. So funny enough, the dactyl that you got was actually printed on the Ender 3 that I turned into the 400 by 400 by 500 monster before I completely disassembled it. It was like 2 or 3 years ago I printed that thing out. I was actually really glad I was able to find the 3D files for it, because they were buried in a Geek Hack forum thread. And in case I didn't say this earlier, you just want to make sure that the line on the diodes lines up with the thicker sided line on the pads themselves. So you can see here, I've got the arrow pointing over here, and then that. So. Yeah, I lined up the line on that.
this is only the beginning.
Oh yeah, the details on the PCB. Yeah, I found when it comes to helping people on like the Discord and forums, it's really helpful to have like labels for everything. So when they have a picture of an area that they find a problem in, I know exactly where it is and I can kind of look up the traces. Otherwise, I'm doing a whole bunch of guesswork, which isn't fun. So the all the labeling is really helpful for a lot of reasons. Actually, the whole front side of this is completely blank. I was going to do some sort of silk screen art, but couldn't really decide on anything. Plus, I have the artistic talent of a potato, and I didn't want to like just steal art from somebody, so. Oh, and there goes a diode flying off. This is why I include extra. Oh, great, we got a rando in chat trying to offer me promotions. And I lost another one. Oh, oops. Be a little gentler with this. There we go. Yeah, I'm still trying to figure out all of the Twitch stuff and, you know, the ins and outs of what to look out for. I've got a few friends who do more regular streaming, so I probably need to go bother them and see how they manage all their chats. I think a couple of them are big enough that they have like mods and stuff like that, so they probably are on a whole different level than I'll ever be, so. I imagine how much scrubbing people are going to have to be doing in the in the future, just trying to see exactly how this goes together. I've got a friend of mine who is planning on chopping this together into more of a actual build guide for me, and I'll just probably end up doing voiceover on top of that, since I've got music playing in the background, and it'll sound like garbage if he just tries to chop it up that way. To his suggestion. Totally didn't think about that, but not a big deal. I can always just do some voiceover. Yeah, I've done this quite a few times at this point. Quite a few prototype runs. Just every time I do a large run of any kind of modifications to the board, I always want to build one just to make sure that it's not going to have any problems. I've definitely made some bonehead decisions on some routing and tracing that have caused some problems, or just totally blanked out and did not run any traces for certain things. There is a Zodi arm that I totally did not wire up half of the thumb cluster, and that was about a good 2 hours of figuring out bodges to make it work. But luckily that kind of goaded me into doing a few other things with the board, and I think it's probably better off for it. I probably got to get another set in here. The black pill boards have just been slightly weird and unreliable though, so. Oh, interesting. Okay, I will remember that for the future for the audio channels on VODs. I'm just recording this locally as well through OBS. I'm very surprised that it's working so well on this Linux machine. I've got my main PC that has Windows on it, but building QMK on Windows is the biggest pain in the world. It's slow, it's weird, and behaves differently. So I have this as my dedicated Linux build box. And figured I'd just stream on it as well. And man, stuff has really matured on the Linux side here lately for desktop users. As my friend pointed out the other day, it's probably because Valve uses Steam on everything. Oh, yeah, there you go. Thanks, Miles. For the Dactyl, honestly, any of the Pro Micro clones with an RP2040 is probably going to be your best bet. QMK has gotten a little bit too big right now for any kind of fun features on an old like AVR 8-bit Atmega chip. I was trying to make a I made an extra branch on my QMK folder called Zodiark Extra or something of that nature, just to kind of add like, per key RGB matrix and VIA support with that. And I had to disable like 90% of the animations to even get it to build in a size that would fit on a regular Pro Micro. So definitely some sort of RP2040 based Pro Micro is your best bet at this point. That's going to have all the space that you'll need to have some fun. And I definitely recommend having fun. I definitely recommend getting into QMK and messing around with stuff and, just kind of looking into some of the options in the documentation, because there's a lot of stuff QMK can do that I do not even come close to taking advantage of. Alright, almost halfway done with tacking all of these down. Get into the thumb cluster here. So just heat up, roll in, let go. And as long as it's not moving, you've got it on there. Is the level of zoom good for everybody here? I could probably get a little closer if anybody wanted some more detail. All right, that's good to go. So, awesome, thank you. All right, so just kind of go over positioning here. You have the sets of 2 up here, the sets of 2 over here, the sets of 1 over here. The thumb cluster has the 1 over here and then the 2, and then you've got your encoder diode up top by all this fun stuff. So, all right, on to the next board. Okay, start lithium clustering this one. Actually, I'm gonna do this upside down because I tinned the ones on the other side.
What's the matter?
Oh, I broke my pencil.
Here you are.
One sec here. Oh, sorry about that. Moving forward here.
But remember,
Upping the heat on this a little bit. Make things go slightly quicker. That one up there is a little cattywampus. Let me fix that. Perfect.
One, two, three, four.
Dreamt it. Yeah, it definitely takes some getting used to for the first time doing this, but once you get the feel of it down, it's not bad. You start to get an understanding of how quickly your solder solidifies and how much force to really put onto it to make sure that it's actually tacked down. I'm hearing every notification on my phone here. Taking a drink of water real quick. Alright. Okay. It looks like I'm running out of diodes here because I've accidentally tossed so many of them.
Here they come.
I'm going to rid you of your vulgar ways.
Yeah, it's getting a little blobby. Yeah, it's all better. Right. Alright, thanks to losing all those diodes, I have ran out. Luckily, I do include a small bit of extras. Just have a little tiny extra piece here. Let me see if I can dig up, because I dumped it all out on my desk. But anyways, it does come with the kit. I should have some extras over here, though. I'd have to get up to grab them. These are some different ones. These are some of the newer ones I have included with the kits. These are kind of more flat, which I like, and have very, very well-defined printing on them, so you're not going to mistake these, hopefully. As you can see, they got a nice, large pad on the bottom, so Makes for a little bit easier soldering, so these are what's typically included in most of my new kits. So, as you can probably see, yeah, there we go. Yeah, you can definitely tell what the marking is on these. Here, let's do some ultra up close.
I ain't gonna die, am I?
Oh, I did that a little away, didn't I? No, I was doing the wrong one. That's why. Skipped one. Don't want to do that.
I'm not afraid.
All right, and that's it. Looks like I got, oh, nope, I missed one. We'll just have a key not working when you try to do that. I missed two. Man.
Even 10 minutes is a long time to be away from you.
Okay. First hard part's over. Now all we have to do is come back in and tack down the other side of each of these diodes. So just get that up here, move this last diode out of the way, and just start going to town on these. So, do the first few up close. Zoom out a bit for this. Okay, cool. All right, that one didn't quite go. You can see it's a little dull. There we go. Much better now. It's flowed. Accidentally tinned that pin, but it's not a big deal. It's gonna need to get tinned anyways later. My phone is doing fucking buck wild. All right, I think I got all of these. Yep, looking good. All right, diodes are all on that one. Move on to do this one. Got a little bit out of the glare there for you guys and gals. A little bit out of the frame there. That one's a little dull. There we go.
Get out of here, get some fresh air.
All right, that should do it for all the diodes. Get the whole PCB back in frame here. See if I can get it up a little further here. Just check a couple things here. Might hear some garbage in the background here.
Dang good to.
Yep, there we go. Okay, cool. All right, so on to the next step here. So we're just going to be doing the hot swap sockets next. As I said, I was doing something a little bit different. So for the bottom row and the thumb cluster, I'm going to be doing the Choc style hot swap sockets, and then for the rest, I'll be doing the MX. So we'll get those going here real quick. Compared to the diodes and pretty much everything else, these are pretty easy to do. As you can kind of tell with this board, this was one of the first prototypes for the final production version that I was doing, and they got the left side, or the right side correct, as you can see here. The individual holes, the 3 holes there, and then that, to kind of align everything correctly. I don't know why, but somebody decided for the other side they were just going to slot just a line there. You can even kind of tell where the circle's supposed to be. If you look right here, you can see kind of like the outline of the circle in the relief there. They just didn't actually drill it. They just made a giant slot. Luckily, it doesn't really affect fitment that much. So I didn't sell any of these. I think there's only one more of these left. I think I gave some to some of my guys who make cases, just because Choc, they wanted Choc anyways, and Choc fit perfectly in these. So, all right, so I'm just going to place the Choc style over here. Oop, there we go. Choc hot swap socket. Gonna go grab that one because I don't have a lot of these left. Gotta place another order for them. And I just hand place these, nothing too fancy about it. You'll see on the board I do have outlines on where they should go for either Choc or MX. There is really only one way they can go in this setup. I did have some people accidentally putting in the MX hot swap sockets upside down. That is why I added the outlines to make sure that people don't do that, because if you do put the MX style ones upside down, it will cover the middle hole, and then you'll end up possibly ripping out some traces. So, all right, so I placed all these. And then typically just to kind of keep my flow going, I'll just do one side, flip the board over, and then do the other. So, and then typically I put a lot of solder on here. Ooh, alarm going off. Ignore that, please. So, I typically like to put a lot of solder onto here just to kind of flood it, keep it nice and stable. You do want to make sure that it is covering the pad, kind of spreading out to the top and the bottom of it so that you've got a stable connection. As you can see there, it flows pretty well. For the hot swap sockets, I definitely recommend the hotter the better. I'm at about 350. I could probably stand to go up to like 370 on this without a problem. And normally I'll probably go back through and hit these and make sure I press them down so that they're nice and flush on the board, preventing any problems. And you just want to make sure that your joints are nice and shiny. This one's a little dull, which may mean it's a little cold, so I'm going to add that with a little bit of more solder to kind of clean that one up. All right, and then I'm going to flip it over and hit the other side of all of these. All right, that's done. And now I'll move on to the MX hot swap sockets. Yeah. So the Kale hot swap sockets that I have for the MX did recently change a little bit. They now have like a little tab on the top. They say it's for increased stability. I'm probably more on the side it's cheaper to manufacture. It definitely makes you have to go in at a little bit of a different angle, but they shouldn't cause many problems. I am gonna need more solder. Where'd you go? Where'd my reel of solder go? Oh, it's sitting right next to me. Alright, have I waiting for it? Oop, oh, there we go. First mess up there. Not a big deal, just put it back on there, reflow everything, and let it sit. And I'm gonna add a little bit more here. There we go. Put it all the way up to that thing. This makes it a little bit more difficult to do. Just kind of have to come in from the angle on the side here to kind of get it flowing. I'm just going to toss this. That's a little too thin. I'm not burning my fingers. Oh, and once again I pulled it. Yeah, this is typically why I usually put a finger on it before I pull my soldering iron away. Keeps things a little easier. Let's solidify. A little windy here. That one needs a little more. Ooh, did it again. Yeah, that top tab makes it flip off. Okay, let's give this another go here. Come in from the side. That's probably the best bet. Alright, time to open up another one. You might hear a very angry cat in the background. I don't let him in here because he tries to chew on wires and not necessarily looking for an electrocuted cat. So.
Leave the car here.
Come back here. Yeah, these new style ones are going to take a little bit getting used to. Okay. All right. It's a little bit better. Don't necessarily need the overhead when I've got this much natural light. And tried to escape on me. Oh, nope, didn't try. Did escape. Almost burnt the shit out of myself. Okay. There we go.
We were riding in the cemetery.
Well, it's 8 o'clock and it's still light.
Okay, cool. Next step is to flip this guy over. Hit all the other sides here. Should be a little quicker since they won't jump around. Might be picking up my cat screaming in the background. He's perfectly fine, although it does sound like he's dying. Alright, so hot swap socket's all done on this side. Just got to do it on the other. Going to give my cat a little bit of attention, since he is very upset right now. Hold on a moment. Come on. What are you doing? Ooh, sure you guys want some cat tax. Ooh, let's try and do a stop there. Ooh, say hi to the internet. Hope he is so blown out. All right, is that enough attention? Are you happy? No, you do not get on the desk. I appreciate you wanting to participate. You're not. All right. Say bye, Ghost. Woo! No. Get out. Oh, man, he's back to screaming. That was apparently not good enough for him. Okay, let's get this set back up in this area I wanted in. Okay, so let's start back up off with the Choc side. Nope, no, that's not where that one goes. Could definitely see myself going into autopilot and putting chocks on everything, but that is not the goal for today. Test, test, test. Okay, yeah. Just making sure my levels are okay still. There. You stay there. No running off. All right, almost out of solder here. There we go, just drop and go. And he tried to escape. Get back in there. There we go, solidified. So when I was mentioning that some people were putting them in upside down, you can totally slot them in like this. As you can see, that is going to lock the middle hole from being used. So once you put a switch in, it will run into the bottom of this and quite possibly tear the pads out. So don't want to do that. Make sure to follow the outline and make sure these are all aligned. And I'm not just saying that other people have done it. I've done it. I have, I think my first hot swap board, I did that and I was trying to figure out why it was so hard to get my switches in. And yeah, they were upside down. That was really fun to correct. I've yet to this day to invest in a hot airflow station, which I think I should probably do soon. Especially when I'm getting to some of these smaller connectors and things like that. Really help me fix things up if they go wrong. Oh, I'm a little out of frame. Oops. I'll do these and I'll move down.
Don't call on me.
All right, perfect. There we go. All right. Time to just do the other side of everything here. Nope, just realized I did not do the other side of this one. Oops. There we go.
Bullet hit the bone, broke it, I guess. He's bled a lot.
Nope, didn't get it on the pad on this one. Definitely want to make sure that it's actually on there. Prevent any kind of rip-offs or pad breaking. That's never fun to fix. At that point, you're super gluing or using epoxy and then bodging it. All right. Looking good so far. Okay, so that concludes all of the hot swap sockets. So should be good to go on that. So next up is the LEDs. Let me take a sip of water real quick before starting on that. All right, so what we'll be starting on here is the per key LEDs. These are SK6805s, something like that, or 3s. So these are actually the lowest current version. They're not as bright as the normal ones, but for a keyboard, they are far more than necessary. This allows you to be able to have a ton of LEDs on the keyboard and not run into the USB 2.0 limit of 500 milliamps. So, because each one of these only consumes 3 milliamps compared to the normal SKs, which were the only thing available up until a couple of years ago, which were 12 milliamps each. You ate into that 500 milliamp USB power budget real quick when that happened. Is somebody at my doorbell? Who are you? Oh, it is the mailman. All right. So, let's start getting these put together. As you can see here, I do have the pads labeled for each pin. You have, let's start over here because this is technically the first one. You have your data in, you have your ground, you have your positive voltage, and then you have your out. So these are all in just one chain. So each one of them gets its own ground and power, and then the data comes in from the microcontroller into in, through it, and then it goes to out. So in this one, I have them labeled LED 0, 1, 2, 3, so on and so forth. That's the order that they go in. So if you find that you have one that's out, typically you'll have one that you'll have a string of them that'll work, and then you'll have one that works and then the next one doesn't. At that point, what you need to do is you need to look at the out pin of that particular LED and make sure that's soldered down correctly. If not, it might mean that the next one in line that's actually off is dead. You may need to unsolder that and replace it with one of the extras that I include. Or it means that maybe this one is also possibly dead. So if you have one that's dead, you replace it and it's still dead, you might want to replace the one that's actually on right before it in line, because you may have messed up the data out pin on that LED. So just some common troubleshooting steps for these. But beyond that, let me get these installed here. Kind of give a good example. All right, just gonna dump these out. So the ground pin is typically the pin that has the little chipped portion, the notch in it, the chamfer. Turn off the overhead light here and turn off this light. There we go, a lot less glare on that. So first and foremost, I'm going to just put these in with tweezers so you can kind of see everything. Just aligning the notch up with the ground. And as you can see, the ground also has a little tiny dot on it indicating the orientation. Just drop it in there and it should just sit flush. Going to repeat that with a few of them. Do note that the orientation changes every row since it does snake back and forth. So as you can see here, the ground is on the bottom. So for that one down there, I would want to make sure that that notch lines up. So just be aware of the notations here that I have on the board for these. You should be good to go. Do note that the ground pin is typically going to eat up most of the heat that you put onto it, so that one may need a little bit of finesse to actually get a good solid connection. The other three pins don't really have too much of that heat sink, but the way that I made the design for these, I also use kind of a hatch pattern for the ground fill, so there's a lot less thermal mass to suck up all the heat. So this is a little bit easier than it has been on other Zodiark boards. So shouldn't be that big of a problem. But as I said before, typically I like to use more of like a chisel style tip for these. So I'm unplugging my version 2 pencil, and I'm going back to my version 1 that has the more chisel style tip on it, so I can kind of lay that flat, giving that a second to warm up. As I said, also, typically you want to run this a little bit cooler. For people who are not super used to doing this, I would personally recommend going down to more of like a 280 to 290, and just be aware of how long you're holding the soldering iron to the pins of the LED, because that's what kills the LEDs, is too much heat. They're pretty sensitive to that. As somebody who's got some experience doing this, I'm going to pop it up to 320. I kind of find it easier that way, and if you start getting pretty good at kind of tacking these down and you want it to go a little smoother, I would definitely recommend pumping up the heat a little bit. Just do be aware that you are increasing the risk of burning out an LED as you increase the heat. I personally have forgotten to take this soldering iron down from 390 and started soldering on LEDs, and I was perfectly fine. But then again, I do have a lot of experience doing this, so I am very quick and I'm not letting the heat soak in very much. So let me just get this tip cleaned off here. Start getting these kind of put down. So typically I'll start with, like everything else, just do the right side and then flip the board over and do the other side. So you got ground here, and then I usually hold that down. And as you can see, I have a very nice shiny connection that goes over both the pin and the actual pad. So that's kind of what you're looking for. If it's dull, you might want to hit it again. So yeah, that, yep. Another great one right there. And then I'm going to move down for these and do the voltage and the data out. Do know that if you don't hold the LED down after you put the first leg, sometimes when you pull the soldering off, the surface tension of the solder will pull the LED kind of out of the slot. So typically when you're pulling your thing away, I use the actual solder to hold the thing down. So, and then I let it solidify before moving on. And then for the second pin, that really doesn't matter. It just is there. So, get this guy over here. And if you see like a little line in between, or you're starting to get some smearage, just add a little bit more of your solder on there. That should add a bit more flux if it's a rosin core, and kind of smooth that out for you and kind of give you a better flow of solder. So, since we've already done kind of the close-up here, let me flip this over. And let's get the other side.
So what?
And honestly, you don't have to make sure the whole thing's flooded. Just make sure you're not getting any kind of bridges, and you have the tips kind of put together. Some of them will be a little bit just kind of dots on the end, depending on how much air you have moving around you, and quite a few other things. So as long as you can see that the tip of the leg is kind of melded with the pad underneath, you should be good to go. All right, so now that we've done some close-up ones, I'm going to zoom out here. Oh, somebody's doing some street racing outside on Kings Highway. That's fun. All right, and I'm just going to wait for this to focus again, and I'm just going to place everything here. Or at least do it a couple rows at a time. And I'm just going to do that by hand here. LEDs are definitely the most tedious portion of this build. Since they have 4 points apiece. Sometimes I'll get a little bold and just start doing 2 legs at once, just kind of covering the whole thing. And then just swiping across and hoping that the solder will stick to both the legs without bridging anything. Just depends on how my solder's doing that day and how well the pads and the legs are taking solder. Over time, these legs can oxidize a little bit, especially if they're exposed to moisture, which makes it a little harder for them to take on solder. But these are brand new and haven't been out of a desiccated bag for more than a few days. So these are taking solder really well. So not too worried about these. So as I was saying before, sometimes I'll just hit both and just kind of flood it a little bit with solder, and then pull away a couple times, and boom, both legs have a good connection there. But if you're not confident, and normally I can only do that because I am running a little hotter at about 320, if you're not confident, definitely go one by one. And if you do have to rework, just be mindful to give it a few moments to kind of soak up the heat before moving forward, so that you don't overheat the port chip. Yeah, see, that one's not letting it take solder for some reason. And then all of a sudden it does. And it's all just heat based. Sometimes you just got to get it a little warm, and then it'll start sucking up solder. And that was a no-go. Let's try that again here. There we go. Sometimes the tip of the solder that I'm using to kind of hold it down is still a bit sticky from being heated. Just got to make sure you have it solidify a little bit before pulling away. Flip her over. And now you can be a little quicker with this because it's tacked down on the other side, so you don't have to worry as much. And see, that's a problem. That is bridged. Yeah, it probably needs a little bit more flux. Yep. There we go. Perfect. Ooh, another bridge. Yeah, I'm spending a little bit too much time on this one. Just gotta be mindful, let it cool down for a second. Give it another go. Still a bit of a bridge there. There we go, that's cleared. I was going great, and then I keep on getting these damn bridges. And always be mindful of the stepping up, because sometimes if you go down or too close over, it will be a different row, and it will be a different orientation for the LEDs. So just always be mindful of the labeling. The notch on the LED always goes to G. Oh, we got a ghost screaming again in the background. Sorry about that. Okay. Let you heat back up a little bit. Well, that one's a little crooked now. Yeah, there we go. Reflow the solder and we're good to go. Alright, that's starting to burn my fingers a little bit. Time for some new solder. Not sure if you can see it right there, but the ground on this one is not quite extending out to the pad. You can kind of see it step down. So that one you'll want to reflow real quick. Oop, and I bridged it. Okay, that's a lot better. It's nice and a bit smoother. There we go. Much smoother. This thing keeps on wanting to refocus, and I'll pop it out a little more here. Alright, 2 rows left, and a whole nother half. Why, thank you, Mr. Blank. Just going for it. I'm just gonna populate all these here. Oh, hope you don't fall in. There you go. for new people, I would definitely recommend doing maybe one row at a time, but when I'm doing these by myself, I am typically just going wild and populating the whole thing and just going up and down. Keeps me in a flow, because switching between soldering and doing this, in my mind, you know, kind of breaks the flow a little bit. Not a lot, just a little. Kind of like going into mindless soldering mode. So. Same thing for the hot swap sockets. I'll just throw them all on and just solder. Because switching between just, I don't know, makes me feel like it's taking longer. Alright, let my iron heat up. Clean it off. And for cleaning these, I mean, I typically just have more of a standard sponge and like brass wire set up with some flux at the bottom. So I'm just going to shove it way down deep in there, and it picks up some of that soldering iron cleaner. There we go. And then I will typically kind of move this over so I'm not brushing any of the non-soldered down LEDs with my hand here. That one's a little crooked. There we go. That one's also a little crooked. There we go, fixed. Now moving on to ground on this side, so they may be a little bit more fighty with me. These I typically want to just try to tack down the ground first instead of doing both of them at once. Just since ground takes a little bit more work, since there's more thermal mass to get through. Sorry, got a little bit of a hair in here. There's definitely a cat hair. One of the downstairs cats. We have 3 cats total, 2 Bengals, and my wife's cat, Ghost. The big fluffy one you saw earlier. Ghost and one of my Bengals do not get along, so Ghost lives upstairs on the 2nd floor, and the 2 other Bengals have the 1st floor all to themselves. So that's how we keep peace around here. Alright, almost done here. And then it is time for a small visual inspection. Make sure I didn't miss any legs here. Nope, everything is looking pretty dang good. Alright, yeah, looking great. Sorry if you hear a little bit of noise there, moving the microphone a little bit. Okay, so that's one half done for the Underglow or per key LEDs. Now to do the whole thing over again. Woo. Take another drink here real quick. All right, so I'm just going to keep moving with this. Let's get this ripped off. We're almost to the fun stuff here. Once these LEDs are done, then we're moving on to getting some of the capacitors, the circuit and VIK connector, and kind of going over what all of these jumpers do. So that's when there's going to be a lot more like informational stuff happening. Right now, we're just vibing out and putting some LEDs on this board. Having the window open in front of me today is a really good choice. It is a nice 73, 74 degrees outside. Nice breeze. Not strong enough to blow anything away, luckily, but good enough. Hopefully get enough air circulating so it doesn't feel like I smoked a pack of Reds after I'm done soldering. Probably need a bit better of a smoke evacuation system for soldering, but I'm kind of limited in the way that this is set up. I might have to do something from the roof and kind of bring in like a connector for like a dryer style tube and get like a nice marine fan or something. But that is a problem for another day. And hopefully, sometime in the future, I change my designs up and just do PCBA, so everything is just already soldered when it gets to me. Still want to sell kits, though, for people who want to do it themselves. But I know there's a lot of people out there who are not confident in their soldering skills, or the possibility of, spending all this money and having a dud that they can't fix. So it's understandable that people would want some sort of pre-assembled available. Ghost, buddy. You're not neglected, I promise. He gets so much attention, and it's never enough.
I'm gonna make you take that chance.
He also just wants to come in here and chew on wires, which is always fun. Especially with, 24-volt raw wires on my 3D printers and all that fun stuff, yeah. Not a great place for him to be unattended. So yeah, my next fun project 3D printer wise is I have an Ender 5 plus the 350 by 350 by 400 build volume version. The kind of like square boxed, still technically Cartesian because it's got the X motor on the gantry itself. It just slides back and forth on the top of the unit. And I did a Exo slide conversion on it, so it's using the Exo slide style, boxed with a bunch of tiny little wheels on them that go back and forth, and it was pretty good for a while, but they have started wearing down way quicker than I was anticipating, and it's starting to get a little loud, starting to introduce some vibrations. The plastic's starting to wear out because it's just kind of tensioned with screws going through the body of the square housing to kind of compress it onto the extrusion. And I think the plastic's just starting to wear out, so it's not quite able to be tightened down anymore. And the wheels are starting to come apart, and it's starting to become a little bit of a maintenance nightmare. And there is a kit out there called the Mercury 1.1 that allows you to convert an Ender 5 or an Ender 5 Plus into a Core XY machine. So at that point, you just get a new gantry. You set up 2 motors on the back corner, and then set up kind of the puppetry style belts that kind of move the gantry back and forth. So if both motors move one way, it can move the gantry up, or the Y back and forth. If both motors go the other way, it moves the X over. If they go different directions, it can go diagonal. But it gets a lot of weight off the gantry and allows you to have frame-mounted, bigger, powerful motors, so you can toss that print head around pretty quick. I also got a skeletized gantry, so it's just kind of machined out, so it's just kind of just a little bit of aluminum, which further decreases weight and gives you a bit more of a higher max velocity and max acceleration you can do. So quicker printing. People say that it's pretty close to something like a Voron at that point when it comes to speed, since it does have fairly decent sized extrusions. It's not like it's using the thinner style like 20 by 20s or anything like that. So it's fairly competent, and I mean, it's only about a $200 kit, so cheaper than going out and buying a Voron kit or something like the Soval SV08 that just came out. That's kind of a Voron clone, which, I mean, it is fairly impressive that a $500 printer can do a 12-minute benchy out of the box. That's fairly unheard of in that price range. I'm also looking at some custom multi-material unit stuff like the Enraged Rabbit and a couple other ones. I heard the firmware stuff on the Clipper side has matured a lot, making it not as much of a pain to do. So I'm very interested to try that out. I've already actually got a board for that, the Easy Feed. But I was going to use that for like dual Z leveling on another printer, but never ended up using it. So yeah, just waiting for the kit to come back in stock at Fabrico, and then I'll get that ordered and hopefully get that assembled. I've got my giant Ender printing out fairly reliably at this point, so I feel pretty confident tearing down the Ender 5, which, has been quite the workhorse for me over the years, printing out cases and things like that. So definitely happy to rebuild it into something a bit newer and more modern. and more capable. Saves me a bit of money on the side too, because I'm not buying a whole kit for a printer. I've already got most of the parts from the printer itself. So yeah, I'm just going for broke here, just populating all of the leftover LEDs so that I can just go to town here. Let this heat back up. These pine soles are nice because they've got an accelerometer in them, so they know when they're just sitting there and they stop heating. So, and once you grab them, they start heating back up again. Oops. Okay, there we go. There. That one bridged a little bit. Let me fix that. Still a little goofed up. My wife just pulled into the back parking spaces. She's precariously balancing a drink on the top of the car. Hopefully that doesn't end badly.
We need a doctor. Look at his face.
And the last little bit of this soldering. I usually just toss these little pieces when they start burning my fingers, which is now. No, yep, that's burning my fingers. Let's grab a new bit here. Clean this up a bit. Yeah, that needs a little bit more flux. All right, now I just got to do the other halves of these LEDs. We're making progress. That ground does not want to take it. There we go. Yep, there's a bridge. Give that a second to cool down so I don't overheat it. Yep. A little bit there and there. Nope. And just bridged it again. I do keep adding a little bit of solder because that sometimes will make it flow back onto the tip of the soldering iron and clear it. But yeah, there we go. All the big ticket items are finished. The diodes, the LEDs, and the hot swap sockets. So now it's down to the smaller stuff, such as the Underglow LEDs, the resistors, and the caps for the smoothing of the power for the LEDs. And then it's on to the Lil-CC CC board, the Pico or Pico equivalent, and then finally the VIK connector. So next up is, let's move this out of the way here. Next up is going to be the Underglow LEDs. I did recently switch from some of the thinner style ones. I've got them around here. Yes, I do. These are the more original style NeoPixel 35 by 35s. These were the old style ones I used. They're fairly thin, but they don't have any visible pads on the side, which make them a little hard to solder for people who are not used to it. So these I phased out in favor of the HS style one. These are hand solderable. That's what the HS stands for. Let me just pop this package open here. This did require a bit of a redesign because the pinout's a bit different, but these are infinitely easier to put on. They are a bit thicker for people who want as much clearance as possible on the bottom, but they're not much thicker than the hot swap sockets, so I'm not too worried about it. So let me just clear this out of the way here, pop these all out, give you a good idea how these look. So in comparison to the flat pads on the bottom of the other LEDs, these actually have pads that you can kind of see from the side, which make them a lot easier to solder on by hand to these boards. So let's move these out of the way here. First and foremost, I do have, if you look, I do have the notch kind of set up for the where the notch is on the LED itself. So those just align. I don't quite have the same amount of numbering and or lettering on these for that, but as long as you've got the little notch indicator here, you should be fine at that point. So the way that I typically do this is I will tin one of the 4 pads, and then kind of like a diode, heat it up, get it liquefied, and then slide the LED into place. And then at that point, I'll go back and flow solder onto all the other pads while it's tacked down, and make full connection at that point. So I'm going to zoom in to these top 3 here. And just do these real quick. Focus. You're not too close, are you? I don't think you're too close. Yeah, you can focus pretty close there. Okay, that's better. Okay, so typically I will tin the pad that is marked. Oh, gotta wait for this thing to heat up again. There we go. Tin that pad. Gonna do the top 3 here. And then, like I said, much like the diodes, let me line these up correctly with the notch going to the marked pad. So like a diode, I will heat up the pad and then just slowly kind of slide this in there and just kind of make contact and touch. That's looking a little sloppy, so I'm going to hit it again here. Yep, okay, that's on there. Probably could stand to be moved up a little bit and kind of out. All you gotta do is touch it and boom, you can maneuver it around. It's a little blown out. Let me... Oh, yeah, that's not great. That's... On second thought, that is not a good... This is not great for my first example, guys. I'm sorry. Okay. There we go. That's a lot better. The problem is the more you go in and rework it, the tackier the solder gets. So sometimes you have to introduce some new solder. And actually, for these, I'm going to switch back to my round tip. I think the chisel tip is doing it no favors. Take that down. Gotta give this a few seconds to heat back up. There we go. That is a lot better. Yeah. Okay, cool. Let's move on to the next one here. Always remember, notch goes to the pad with the little white notch on it. Let me heat that up. Touch it. Oh yeah. That is way better. Far better example. Yeah, for that one I definitely want to use the more conical tip. Okay, next one up. Actually, let me get you more focused on the middle here. Okay, so just heat that up. Approach. And then, boom, yeah, there we go. I'm going to get the other side taken care of now. Flip that over. And luckily you can kind of see the pads and everything over here, so just hitting the pad and filling it with solder. And yeah, it should automatically just flow up and kind of blob onto it. Yeah. And sometimes if it's a little gray, you might want to try giving it a couple tugs. There we go. Yeah, that looks great. All right. And now that they're tacked on the other side, I'll typically go back, flip it over again, and get that last pad. I did the top one already, but this one right here needs it. Luckily, there's only 20 of these total, so far less than the other ones. So let's pull this up here. Focus. There we go. And just to kind of point out where they all are, you've got the top three at the very top. You've got the middles right here, and right over here. And then the bottom are at the very bottom, right there, right there, right there, and right there. So let's tin all these and get moving. This one seems to have gotten some, is that solder? Yeah, that one's gotten a little solder on this pad right here, so I'm going to tin that pad instead. And we'll just figure that out when we get to it. There we go. And just pay attention to which one is marked for that. They should stay the same since they skip rows, so I shouldn't have to flip orientation. I'm going to skip that first one since I have the different pad tinned since I accidentally got solder on it beforehand, so I'm just going to move on to these.
Oh, it's late.
I do include quite a few extras of the LEDs, I think 4 apiece, just because they are the things that can get messed up the most easily. So definitely want to give some extras so I've got a chance to swap stuff out and get it fixed. That's a little crooked. I'm going to fix that. I don't like how that one's set. Okay, that's a little better. Flip and do that other one. I'm just going to tack the other side down just to do it. Okay. Just finish up the last one on each of these. All right, and that should be all of the underglow that we need. So 3, 6, 9, 10 total. So just got to repeat those steps over here. And as you can see, the notch is in a different spot. So it's the notches on the top for these three. Well, all 10 of them, actually. So do have to flip orientation per side. Okay, and no, just as a refresh, I'm going to tin just one of these guys. Doesn't necessarily have to be the one with the notch on it, since the notch is on the other side. Well, that's a little much. All right. Okay. And once again, just note that that's where the notch should go, that guy to that guy. So notch is in the top left on these.
Dad, are you sure you know what you're doing?
It's a little crooked. Fix that. All right, time to flip and get the other two pads. Sorry if there's a bit of wind noise here. He's picking up outside. Helps me out. Get some of the soldering smoke out of my face. Oop, almost bridged that. Walked out. Didn't stick. So, sadly, with the way that it's set up, there's no real way to skip the down firing. You would have to run a bodge wire between a couple of the pads. I can provide those pads if you wanted to do that, but at the end of the day, it'd probably be better just to install the down firing LEDs. In the future, I can probably add a jumper that does that for you. I just didn't do that. I haven't done that on any of my designs yet. But good question. Thank you. Well, I'm glad they're starting to show up. I think I did the timing just right, eh? Got everything shipped out Thursday? Yes. Everything was shipped out Thursday. Don't like that soldering blob there. Ah, much better. Oh, bridged. Nope, don't do that. Okay, perfect. Okay, cool. That's all the downward firing LEDs. Now we're just moving on to a bit of housekeeping, some miscellaneous stuff, resistors and capacitors. At this point, you'll be popping apart the small bag and getting all of the parts out of that, such as the VIK connectors, the Lil-CC C boards here. Oh, that stuff. Get out of there. You're not supposed to be in there. Some of these will come kind of together at that point. You just give them a good snap and you're done. Your tack switches. Just dump all the rest of this stuff out here. Your 10K resistors and your caps. So I guess first thing we'll do now is we'll start off with the caps. These help smooth the power going to the LEDs, so you don't get any flickering or any oddness when they suddenly change to white or something and pull a bunch of power at once. So, just like a diode, tinning the pads for these. It looks like that one was already tinned off to flop that. And then just notice that this one's kind of over to the side. You got 5 total on each board. So 10 total. Oh, come on. These are a little difficult to open. Let me try from the other side here. There we go. My bad. Okay. Oop. Where'd you go? Where'd you go? There you are. Okay. Flip you over. Alright. These don't have polarity, so just grab and go. Neither do the resistors. Alright. So let me just grab one of these guys. I'm going to turn the heat up a little bit on my iron since we're done with LEDs. Alright, and then very much like a diode, just get it in there, touch it. Ooh. Make sure it's nicely evenly spaced across the pad so that you don't get any accidental shorts. Oh, that one I'll have to flip for, since I accidentally had some solder on it. Placement of this one could be a little nicer, but it's getting a little crowded over there. Alright, flip it over.
That's why I called you so late last night.
Just flip this one over as is so I can just take care of the other side of it. Oh, that one did not flow to the pad. There we go, much better. Move that off a little bit. Perfection. Okay, that's all the caps. Now to do it again on the side. Okay. Focus. There we go. Alright, and then you just hit it on this, slide it in place. Ooh. Sometimes I even forget where stuff is located. And this one right here, just be a little careful since it is very close to the pad of that hot swap socket. Alright. Flip and take care of the rest of these. Okay, that's good. All right. That is all 5 capacitors on that one. All right, next we move on to resistors, or well, 1 resistor per side. This is just to let the keyboard know which side it is, left or right. There are other ways of doing this in firmware, but this requires no user intervention when it comes to flashing or doing any fancy stuff like that, so it's the best way in my opinion. So also no polarity on these, so don't worry about it. And we're only populating the one labeled 10K. The 4.7K are for people who want to do hacky stuff with I2C, so I'll let you guys provide your own resistors for those if you were going to mess around with that. All right, on the other side. Oop. There we go. All right. Okay, now, before we move on to the top-mounted components, I'm going to start trying to set up the VIK. So this connector is a bit small, very, very, very small pitch, but I do have a couple techniques that will help make sure that this hopefully goes smoothly for most people. All right, so let me... So first things first, we'll want to make sure that we get it as aligned as possible with the pins. So I usually will come in and tack it down from the side on one of the larger pads for the mounting side. So first things first, kind of like a diode, we're just going to take this large right pad for the mounting side, and we're just going to solder that. And then I'm going to grab the whole connector. And then just slowly kind of slide it in while heating this up. And then make sure I'm lined up. Oh, almost had it perfect. It's a little cattywampus. Let's see if we can nudge it just a smidgen. Ew, nope, messed it up. Yeah, almost had it. Now it's trying to lift up. There we go. Almost have you. I am melting the ever-loving bejesus out of the side of this, but should be fine. Oh, I think I'll call that perfect. Still opens and closes, we're good. Okay. So next step is typically going to be, for me, to just kind of flood the pins. This only works if we've got the solder wick here for these steps, so I'm going to assume you've got that for this technique. So I'll get a little sticky here. I'll set it up a little hot so that it'll flow nice and quickly. So just kind of... there we go. Okay. So as you can see, you've got a nice big blob of solder on there. Not necessarily what we want, but we can resolve that by chopping off a little bit of this stuff. I also would recommend putting a little bit more flux on there as well. Got my flux pen. I'm going to hit it with some flux, and I'm probably going to flow it again here just to kind of get it on everything. There we go, now it's flowing out of the pen. Put that down and... okay. So now, take this little bit of solder wick, and I'll put it up against it. I'm going to preheat it just a smidgen. Okay, and get it in there. And start to see it kind of suck up the excess solder. Leaving it fairly clean. As you can see, it has pulled most of the solder off. So let's give it a nice little visual inspection here to make sure we don't have any bridges. Hopefully it'll decide to focus a little bit. Maybe I need to bring it down. Yeah, most of that is just flux paste. So that's actually looking really good. So at this point, I'd probably grab my little brushy guy. If I remember where, there it is. So, I've got my little chemical brush here, and I've got some alcohol off screen here. It's 99% IPA. Not the Indian Pale Ale, but the isopropyl alcohol. Soak the tip in that a little bit. Ooh, that stuff stacks. And I'm just going to clean the excess flux off here. You can do this for the entire board, but I mean, I use no clean stuff, so I'm not too worried about it. Plus, if you don't have 99%, it can cause a giant sticky mess. And then, at that point, I'm just going to get the other pad here soldered down. And done. That is a clean VIK connector. So, next up, all we really got to do is figure out if it's actually making contact on all of those, which is going to require this guy right here and an extra cable I've got laying around right here. So first things first, let's get this plugged in. I'm blocking it. Alright. And there's one side, and then the other. What's on? All right, and this gives us test points to check to make sure everything's making contact. I'm gonna zoom out a lot. Start testing. So I'm just gonna change this to, oh, are you dead? Don't tell me you're dead. No, you're not dead. Cool. All right, got this in continuity mode. All right, starting with one pin. That might be ground, so multiple of these will probably end up going off. Or it's power. Yep. Okay, nothing else going off. Cool. Pin 2. That's, I think, ground. And then that's going to be a bunch of them. Yeah, because there's multiple grounds on the Pico. Moving to pin 3. Okay, nice. Let's make sure it doesn't pop up with anything else. Cool. Pin 4. Nice. Pin 5. I think I might have missed one over here. Okay, and some of these pins, if they don't go off, are going to be the pins over here for the VIK enable. So... or pin 5's just not connected. What is pin 5? That's a great question.
From a husband who planned a trip on which he intended to destroy his wife and did kill her lover.
Looking that up right now. Oh, okay. There we go. That's one thing. So pin 5 is actually the RGB out, which isn't bridged over here. It is a is one that you would have to bridge to be able to go through. So pin 5, popping back over, and let's hit RGB bypass. Yep, there we go. Pin 5's good. Moving on to pin 6. I'm gonna check these 3 guys here. Yep, pin 6 is this. It's not touching any of the other ones. Pin 7, probably another one of these. Yep. For the VIK enable. It's just that these have to be routed differently so that you're not burning out a circuit. Why don't I just do 7, right? 8. 8, I think might be one of these guys. No? Okay. Flip it over and go back to the Pico pads. Okay, what is pin 8? What is pin 8? 3, 4, 5, 6, 7, 8. 8 is MOSI. Interesting. Do I just have a bad connection? Let's do pin 7 again. Oh, there we go. I guess I was skipping that one. Whoops. Had me worried there for a second. All right, 8. Moving on to 9. Let me try to right. Yep, moving on to 9. Okay, what's 9? That should be one of the digital analog pins. I think it's one of these guys. Interesting. They're just not making good contact. Let me just double check this on my schematic. Oh, this is an ancient version. Okay. CD. Sorry for the hold up, guys. Okay. There we go. Now I can open KiCad. Sorry guys, just doing some fun housekeeping stuff here. And I am going to put out a guide for how to test these to make sure you know which pin goes to what. I have a feeling this is just the one on the back here. Huh, yeah, it is one on the back. Oops. Okay, cool. So then that's going to be one of these guys here. Honestly, it's probably the best practice at this point to bridge these three if you're going to be testing, just so you can just rake across the front pads here for the Pi Pico itself. So, oh shoot, which one was I on? I was on one of these. 9, right? Okay. Crap, which one was I on? OC is number, so this should be number 9. Mine doesn't seem to work. Let's see what 10 goes to.
Feels good.
It's supposed to be clock. Well, either that means there's a bad cable, or those are not connected. Going in with my phone camera real quick here. Oh, looks like I might have a short too. Alright, I'm gonna hit this real quick. Yep. Gonna hit y'all with some flux here. Alright. And then we have another piece of this stuff. Some braid. Grab that tweezer so I don't burn myself. Put it in here. Yeah, it's looking way better. Okay, back to continuity testing. I think this cable's a little beat up. I'm gonna steal one from something else here. And I am just going to preemptively bridge all three of these so I don't have to keep swapping back and forth. I'm also going to hit the VIK RGB jumper as well. Can always unbridge these if I was going to plug the circuit in, so. Alright, cool. That should simplify my testing. Okay. Alright, let's flip and go. Okay, starting over again here. Start with 1. Got a hit.
You just gotta realize that everybody's gonna be
2.
on your tail from 5 o'clock until the day you die. That is, unless you were standing in a puddle of water and then you'd be grounded. If you were grounded, it...
Okay, so we got hits on both 1 and 2. So 1 is 4th down on the right. Making sure it doesn't hit anywhere else. 2. 3rd down on the right. 3. I think 3 is ground. So 3 is going to hit on a lot of these, I think. Oh, maybe I'm wrong. Oh, there we go. You know what? Probably help if I had that up. Okay, so let's start this over again. I'll make sure to clip this part out here. So 1, that's 3 volt. 3 volt. That's going to be 5th down. 2 is ground, so that's going to be a bunch of them. So that's going to be this one, this one, this one, this one. There's a ton of grounds on the Pico for some reason. Next up is going to be number 3. That is SDA. So that's going to be this guy or that guy right there. 4 is going to be SCL. Yep, so that's either that one or you right there, second one from the bottom on the right. Next up is 5. That's going to be RGB data out. I think that's somewhere over here, if I recall correctly. Maybe not. Maybe I don't have that bridge correctly. 1 second. Okay, check that on the other side here. Okay, 5's not going off anymore. Let me check 6. Six is 5 volts. That should be one of these guys. Yeah. 7. 7 is going to be digital I/O 1. Okay, right there. Make sure it doesn't pop on anything else. 8. MOSI. 8's good. 9. Another digital. Yep. And there's that. Huh? Ooh, looks like we might have a short. Which one's that one? Miso. Miso MOSI. Let me pull out the camera again. Ooh, I do see a little bit of a thing going on there. Okay. Could be right about where we were at anyways, too, so hit that with some flux. Oh, inadvertently braided more stuff. Eyeball test looks good. Let's check that again. All right, yeah, cleared that short. 9 is good. Let's move on to 10. Should be one of these guys. Yep. There we go. Let's make sure it's also one of these. It can be both. Just you don't want 2 pads on this going off for anything other than ground. 11 is miso. That's going to be another one over here. Is it? Yeah, there we go. Okay, cool. Oh yeah, miso, only data out. Yeah, well, data out to the screen is on the screen connector, so yeah, that wouldn't be on here. And then last but not least is clock. Yep, there's clock. Make sure nothing else goes off. Cool, we're there. The only thing that didn't pop up is RGB, but maybe after I did that, maybe that'll happen. So RGB would be number 1, 2, 3, 4, 5. Strange. Maybe if I clear this. Heat up, coming. Take a look here. Okay, RGB is connected to that 5th pin. Goes down to the bottom of that bypass. That should give me a connection. It's connected. Did I mess up the via by chance? Well, it's just RGB, which I don't think any of these really have at the moment. And I have had it go off on other ones, so I'm not going to worry too much about that one, and we'll move on to the next. I'm just going to put a VIC connector on both of these sides here. Alright, hopefully this one's a bit more cooperative. That's the first time I've really ran into any major problems here with VIC connectors. So hopefully that is an outlier and not what happens every time. So moving down here. Focus, there we go. Let's give this another go. So first and foremost, I am just going to bridge the VIC enable pins. Okay. And then I'm just going to hit this guy right here. Let's get this in place first. Yep. No running off, please. Actually, you know, it might be a little easier if I open the clamshell connector. Yeah, actually, that makes it a lot easier. So flow that. The pins aligned here. Well, I don't think I could get that any better. Yeah, I don't think I can get that better at all. Okay, cool. Let me hit this with some flux. And actually, what I probably want to do to make it so it's a little easier is to close this up and hold it down while soldering down the other side, just so those pins are making contact. Let's get this in here. Get this up a little bit. Yeah, okay, there we go. Now it's focused. Okay. Alright, so next up is now flooding the connector. Alright, so connector's flooded. Now to chop off another piece of solder wick. And then come in and clean that up. Before I do that, just to increase my chances of success, I'll get that cat hair off here. No, is the cat hair just permanently attached? Nope. It might be burnt into that. Oh, that's just complaining that I left it on too long. So, add some more flux. And then just gonna preheat this a little bit. Alright, and then time to go to town. Okay, almost got it. All right. That's looking pretty clean. Take a look with my camera real quick. Oh, stop complaining. You're fine. Yeah, that's looking good. Okay. So let's do the testing on this one again. Okay. All right, let's flip this bad boy over. No, actually, let's do it this way. Okay. Now for testing. Turn my meter back on. And we'll place the meter next to the microphone so you guys can hear it a little bit better. Oh, that's not continuity. There we go. There's continuity. All right, so starting off, 1 should be 3.3 volts. That should be somewhere over here. Yep. So that's number 5 on the right. Make sure nobody else is yelling. Okay, number 2, that should be ground. So that's going to be a bunch of them. So, yep. Yep, so ground's good. 3 should be 5 volt, which should be over here somewhere. Or is it over here? Can't recall. Nope, never mind. That's not it. That's a 5 volt. That's going to be SDA or... Yeah, so that is SDA. So SDA will be down here. Last one on the right for number 3. Number 4, it's going to be SCL, so that's probably going to be this guy. Yep. Just make sure there's no other short outs here. It's only beeping on that. 5 was the RGB. That I'm going to have to flip it over for. And check this guy. Yep, that's good. Let me just make sure that it's not doing anything else on any of these other pins here. Nope, we're good. 6. 6 is going to be, that's going to be 5 volt, but should be over here somewhere. Yep, right there. Check in elsewhere. I think there's 2 5 volts, technically. I think that's the only one it's wired to, yeah. 7 is going to be one of the digital analog pins here. That's enabled by the VIK connector. So if you don't get it over here and you don't have them soldered, you want to check the VIK connector enable pins. So let's go across here. Oh, there we go. So that's going to be 1, 2, 3, 4, 5, 6, 7's down. Check to see if anything else beeps. Nope, we're good. Number 8, it's going to be MOSI. So let's go through here. I think that's probably down this way. Yep. Final pin on the left side. Make sure nothing else goes off. 9. 9 is going to be the other digital pin, which is on the connector. So if you don't have the VIK enable, you'd have to set that up to get this on the pads. Yep, right there. So that's number 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 9 on the right side. Let's see, number 10. Number 10 is going to be the SPI chip select. Right there. There's the chip select. Okay, nothing else goes off. Next is going to be MISO for number 11. It'll be over here somewhere. Right there. So that is 5th from the bottom on the left side. All right. And then the last one is just the S clock, which is 2nd from the bottom on the left side. Nothing else going off? Excellent. That one went way better. And this is the side we're going to have the pointing device on anyways, so that's perfect. All right. So we can move on now. So please don't let that come off as too scary. It's definitely a bit more advanced, but I do have something coming up in the future to kind of make that easier with the Easy VIK connector. And that's going to allow you to just pop one of these already assembled onto a board, very similarly to something like the Lil-CC, where it's just, still 8 holes, and you just match them up with some pads. Pretty easy stuff. So now at this point, we are done with everything on the bottom. We're going to move to the top here. So we're going to zoom in to this area right here. First thing I'll do is the easy one. We're just going to do the through hole reset button over here. Oh, Testing Room Podcast. Thank you very much. Love you guys too. All right. That's on there. So just flip her over and hit the pins. Alright. For the reset button, I typically will take some side cutters and I'll kind of trim these down just a smidgen. Put my finger over it so I don't, accidentally blow out the camera. That didn't really get too far, did it? I think that's about as good as that's going to get. There we go. There we go. Smooth that out so if you're running it without a bottom on the board, you're not scratching up your desk or catching any of your fancy, beautiful desk mats. Next up is going to be the Lil-CC board here. This is your C2C interconnect. So typically, I will just do this same as most of other ones, just, hit one pad. Make sure you give it a good amount. There's some big vias in there that'll give you a bit more stability if it gets tugged a little too hard, but should be just enough stuff to hold it on there without causing any problems. And then just hit that and just kind of align everything. All right, so let's get this centered here. So yeah, that's pretty well centered. I'm gonna probably just tweak it just a smidge. Nope, I made that worse. There we go. That's pretty much as good as that's going to get. Okay. And then at that point, I'll just start flooding these, get a good connection. I just put a boatload of solder on these. You don't have to, I don't think. I do, because just in case something happens, I want a lot of solder in there to hold it down on there. So I'm not ripping up pads. Okay, that's starting to burn me. All right, new solder. All right. All right, flip it over. Uh-oh, that didn't even touch the pad. There we go.
She feels warm. Maybe it's shock.
Okay, and there's the Lil-CC. That's on there nice and flush. And then for the final bit, we just got to find out where I put my... Where did I put those? My wave share boards. Oh, there. They were underneath the trackball. All right. Same principle. Just want to tack it down on one of the corners and then go to town. So line that up there. Looks good. So I'm going to move this a bit towards me. Okay, yeah, it's still in frame. So I will just do the top corner here. Flood that with solder. And then just kind of bring this guy in far enough so I can see everything. Pretty even on both sides. Oh, oops. Caught my headphones on the desk. Oh, I would say that's perfect. Could probably stand to be pulled up just a smidgen. Okay, yeah, no, that's about as good as it's gonna get. Okay, I'm just going to start tacking this down here on each corner. So flood that pin, press down, wait for it to solidify, move on to the next pin over here. Up here. Okay. And now that you got it tacked down, you can just go to town on all the rest of the pins here. So just put that in there. Sometimes you kind of have to poke around to kind of lead it where you want it to go. Just watch out for bridges, but with these pads it shouldn't be a big problem. Just got to keep your soldering tip clean. This one could use a little bit more solder. So could this guy. One of my techniques is to just kind of hold it there and then wait until the solder starts melting, like on the whole portion. And then at that point, you know, you have enough heat to flow everything. But you can kind of quicken the process a little bit by getting a little solder on there and just kind of dragging it around on the pad. Oops. Decided it wanted to stick to that. All right, that's done. Let's move to the other side here. Might want to give it a second because this does soak a lot of heat into the board. So you are shoving a ton of solder into this thing. Oop, you're stuck. Ugh. Ooh, big one. Okay, that did kind of try to shove some stuff off my desk. Turn it a bit here. Give myself a bit of a better angle.
Please let me go.
We can't do that, miss.
It may even surprise you to know that I have positive proof.
All right, and at that point, we technically have a whole keyboard over here. This should be everything you need to get this thing running. So let me repeat these steps on the other side, and and then we can get to testing. And we need a little bit more solder here. Yeah, it's not doing much. Let me see if I can get a better grip here. There we go. Much better. No, stop it. There we go. Yeah, good enough. All right, next up, Lil-CC. Yeah, a little crooked. Let me fix that. I think it looks perfect. Oh, I am totally off camera. Whoop, there we go.
Supposing that creature, the one you killed, was capable of taking ideas
All right.
from people's brains.
And then the second Pico.
You mean it sucked other people's brains? Absorbed through the ore.
I'm a little biased by my angle here. Yeah, I think that's perfect. Look here. Yeah, that's about as good as that's gonna get. Let's tack down the four corners.
You only wrote this for the money, didn't you?
Getting ahead of myself here. Started going to town. Oh, and I'm off camera again. Yep. Okay, I'm just gonna get this all taken care of here.
Go on.
Give this a second to cool off here for a second. It's getting pretty warm. All right, that does that. Okay, cool. One more thing I'm going to throw on there is I'm going to put one of those hot swap sockets for the LCD over to the side here. Just know that you can skip the backlight pin. So if you've got it set up here, the backlight pin is the bottom. So let's flop it over here. So as long as you're in the square peg at the very top, 7 pins is more than enough for this, so shouldn't be a problem with that. So typically I'll just kind of flip this over. Yeah. Make sure it stays up. There we go. And then just kind of tilt it until it aligns to where I want it. That looks pretty centered to me. Yep. There we go. That's fairly centered. Boom. 1 down. 2 down. So on and so forth. All right. Hot swap sockets in. That's a little crooked. Let me see if I can fix that. That's a little better. Tilt it to the way I need it. All right, so just in preparation, I am going to get some standoffs on here. So the standoffs typically go for any kind of adapters or screens, or the big screen here are usually these 4 holes here. M2 standoffs and screws should be good for that. Got some right here. Pull this up a bit. All right. Whoop. It's trying to escape on me.
You've had the regular opportunity.
Okay, yep, let me just get these all evened out. All right, and then I'm going to install the screen. Nope. And the last one. All right, screen is installed. Next up, I'm going to install the standoffs and install the VIK module here. All right, so next up we'll install the adapter plate. One of the screws decided to stick around. I gotta get rid of that. 1 second. This is the one that's a bit seen, isn't it? Did reuse these off of another board I was messing with, but yeah, not a big deal. No, I guess this one I'm going to be using that. All right, so this will go on this way. Okay. And this is specifically made for the finger punch VIK board that has the PER ring encoder. Oh, that is a Phillips screw. How the hell am I doing this? Nope, 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 nope. Nope out. How the heck was I threading that in? Okay. Okay. All right. And then for the module itself, well, stop complaining. All right. And then I'm going to get the circuit prepared here. So just plugs into the VIK in over here. Clamshell that. You'll see that this has cutouts corresponding to the bottom of this. Just need to line it up. And there we go. Grab some more screws. And it lines up with the standardized large mounting pattern for VIK modules. So technically this could be adapted for quite a few things. Didn't need to do that. Missing one screw here. That one I don't think's gripping onto anything, but I'll leave it in there anyways. Alright, and then all we gotta do is flip this guy over. Oop. Yeah, just fell out. I gotta reprint that. I think I stripped it. And then we just plug that into the circuit. Nope, that's a little cattywampus. Let me fix that. Okay. Okay, and that pretty much takes care of all of that. The last thing I need to do is install a encoder on this. I'm just going to stick with standard encoders today, but you guys can do whatever you please if you can get your hands on anything. So let's pop this bad boy on. Standard encoders, you'll see that that just slots in to these three holes on the side, and then the two that are in the middle on the other section. So just kind of have to wiggle it on in there. Oh, crush that one. Don't be like me, be careful. There we go, fix that up. Okay, make sure those line up, make sure these line up. All right, there we go. That guy's on. Let's do the other side too here. That one's a little off, let's fix that, yep. There we go, that's seated in there. And let's solder these guys on. Probably should have done this before I put the trackball on, but hey, who's counting? Let's go. right, that's on there.
But we'll have to work together. You'll have to help me.
I guess they didn't make those plated on this one. That's strange. Take a look at that. That should be enough. Okay. All right, so that pretty much finishes all that up. I'm going to switch to my desktop here so we can kind of get some firmware running for these. Where'd it go? There we go. Okay, so moving into here, sometimes you do need to, depending on the screen you choose, you may have to make some modifications to the ZodiarkPi.c. This, as is, should be set up for the ST7789, which is the bigger square screen. You would just be commenting all of this out, and then, let's see, and then uncommenting most of this out for the round screens. So just kind of have to follow the comments I put in. If using a pointing device on things, comment out these lines, so on and so forth. And that should be all you really have to mess with in the ZodiarkPi.c. I know most of the people like the bigger screen, so I left the one in here with the large screen. So if you have the large screen on the left side, no changes needed here. Rules.mk, that is just enabling VIA by default. Matrix drivers, all that fun stuff. MCU config, that's just set up for SPI and SIO. Nothing you should really have to change in the info.json file. There are some additional pins for the encoders. Currently, I don't have I2C enabled. As you can see, I have it turned off for additional pins for those double stacked dual encoders. If you do want to just re-enable, all you have to do is get rid of these two lines here and go back over here and uncomment the HAL use I2C, and in the config, you also want to go in here and uncomment those out. At that point, I do have one more thing I have to go over I totally forgot about. So what we're looking at right now is the jumper pads and what they all do. So first and foremost, we've got if it'll decide to, there we go. First and foremost, we have the VIK enable pins. These jumpers allow it to become the circuit connector to become fully VIK compliant. Do note that this does enable 5 volts to a pin on the connector. So if you have these bridged, do not plug a circuit touchpad such as this directly into the keyboard. That can cause problems because you'll have 5 volts going to a random pin on the circuit. Not a good idea. If you're not using LEDs but you want something on a VIK module to have RGB, you would bridge this right here. Or if you wanted the end of your RGB line to go into the VIK module for additional RGBs, you would bridge that connector right there, or that jumper right there. You also have jumpers here for dual encoder enables. What this is going to do is that's going to kill the I2C pins, the SCL, and the SDA, and that's going to reroute them to these pins over here so that you can have the double encoder on this side that you put it on. The way the firmware works and compiles, you would basically lose I2C on both sides, so you would just have to probably jumper both of these on both sides. Circuit CS, basically what that does is that takes the split hands pin and allows you to use it on the chip select for the circuit. So this one right here is normally connected. If it's hard to see from here, but there is a line. You would cut this one right here, cut that across in the middle, and then you would bridge this guy together to give your circuit or your VIC a dedicated chip select pin. The reason you would want to do this is if you wanted to run both a screen and a VIC module or circuit on the same side of a keyboard. Very rare use case. I put it in there for people who wanted to do hacky stuff. Your mileage may vary with this setup right here, and you would have to find an alternative way to define handiness within the firmware. So do be aware that that's something that has to happen. This is really, like I said, for people who want to do multiple SPI devices on a single side of the board. So, but yeah, that's all the pads and all the setups here. So let's flip this guy over. So at this point, I'm just going to get the keys on and kind of get this semi-assembled here on the top. And then we can compile some firmware and hopefully get this thing working. I have a feeling this is not going to be as easy as I think it is. Yeah, I'm going to have to pop all these out. Weep. Do them one by one. Turn that fan off because I am no longer soldering. Unplug my soldering iron. Let's get moving.
Welcome.
Let's see if I can get this to go on. Oh, okay, yeah. Pop a couple of these out because it's going in at an angle now. See if I can get escape going in here. There we go. How about you? Yep, yeah, you're going in just fine. Yep, looking good. Now for the Chocs, these might be a little difficult. Nope, oh, looks like they're going in. Yeah, it's popping out though. Yeah, let's pop some of these out. Yeah, I don't want to bend any pins. Let's get some out of here. Okay. All right, looking good. No bent pins or anything. Nope, don't like that. Ugh, did I just crush pins? No, they just didn't go in. No problem. All right, cool. All the chocks are on now. Let's make sure all these are in. Oh, those are good. And for anybody wondering, I am using some well-worn kale creams, along with some pink 20-gram G-Chocks for the bottom. The G-Chocks were procured from the MK Ultra store, which recently sadly closed. They were an excellent provider of a lot of low-profile Choc stuff, and the community is definitely, worse off without them at this point. But hopefully somebody will pop into that space and start doing Choc stuff, the cool stuff they were doing. But understandably so, small businesses are very, very hard to keep running, especially if you're a sole proprietor. After shipping out 110 original Zodiark cases and then trying to work a new job and get a wedding planned and a whole bunch of other fun stuff. Kind of fell off the keyboards myself for a minute. But now I'm back in action and getting stuff shipped out. I don't think I'm going to do any more group buys. The pre-orders kind of worked out because I could control how many I could put up for stock just to kind of keep my sanity in check. And luckily I've had a decent amount of free time to be able to devote to getting kits ready and kind of fixing up some of my pipeline and work processes and things. So hopefully I can keep this regular. But now I can completely understand how hard it is to keep a small business going, especially these days. And if health problems were involved or something like that, that makes it just even more difficult. So. Alright, got all the keys on this one. I'm not going to put a bottom half on this one just yet. I typically don't even run a bottom half on my keyboards. But yeah, there we go. Ooh. Ooh, I really like that. Okay. Now let's christen this with Encoder. Alright, one half done. Let's start popping keys over here. I'm actually going to, let's take care of this first. Oh, wait, no, that one is a corner, so I want to keep that. Get rid of Y here. Pop you out. Get most of you guys out. Oh, nope, nope. I wanted to keep you in your corner. Yes. Okay. There we go. And I'm going to pull this off. Pull this out. This little ring guy too. Come on. I had to print out a little bit of a spacer here because you got to have this a specific height above the sensor or else it won't even detect it. So I had to mess around and print out a little ring to kind of fill that space. But works great after that. All right, so let's. Am I close enough? Yeah, I should be in there. There we go. Good positive snap there. Always make sure you're supporting the back of your hot swap sockets as you're putting your keys in to prevent any kind of tragic pad rippage. And then usually I like to check to make sure I can see both the pins kind of sticking through as I do this. So yeah. Yeah, looking good so far. Now I'll move on to the chocks down here. Looking good. And then the thumb cluster. Oh, that didn't go all the way in. Okay, yeah, no, it just needed a little extra convincing. Okay, cool. Time to start putting these all in. The Choc keys do have these little tabs on the side that if they catch in a weird way, you can kind of bend them out to the sides, kind of banana them out. So just always kind of be careful to just kind of give it a good wiggle when you're putting Choc keys in. Oh, like this one, I think I messed up. Nope, nope, I can see the pin, never mind. So let's just continue. And as always, like I said, just make sure you're supporting the back. Uh-oh, picking up some stuff here. Do a little bit of cleaning off to the side here. All right. We are almost there, everybody. Hopefully there's no troubleshooting. Maybe hopefully there is. Maybe there is some troubleshooting needed, so I can kind of go over some of my methods to my madness with you guys. And gals. That one doesn't want to go in. What are you doing? Come on. Nip. No, that one just did not like me, and I think I might have crushed a pin. I think I totally crushed a pin. Grab my good old key extractor. Alright. Okay, man. Let's get you from the sides here. Oh, yeah, totally crushed a pin. Eep. That's one of the risks of hot swaps. But if you're careful, you can fix it. Oh, a little too far there. Okay, you're just broke. Meep. Well then, I'm just going to grab another switch here. One moment. Right. Okay, I got another switch here. I'm just going to check something real quick, make sure this isn't just blocked. Okay, perfect. Get this guy back in here. Much better. So just to kind of go over a couple things here, I think I might have done this a little bit out of order for most people. The thing is that these usually, when they first get plugged in, usually will go into like the bootloader mode because it doesn't really have a program on it. If not, I may have to remove this to get to the boot and reset buttons of the Pico or the RP2040. So just as a heads up, maybe a little bit of stuff going on with that. Okay, so let me share my screen again here. Start my screen here. All right, so this is all looking good to go. Currently, I'd be doing I've already kind of got it set up here for the ST7789, which is the larger screen, and a VIK PWM, which is the mouse trackball dealio with the encoder. So just get that put together here. All right. So at this point, I should just be able to open up a terminal here. And let's see, I'm going to CD into my code, CD into QMK firmware, and then I'm going to QMK compile. Oh, there we go. Let's see, we're going to do ST7789, VIK PWM. I'm going to put a C on the end of that to make a clean one. What this should do is that this should dump out a U.2 file, which luckily is just drag and drop at that point. So you would just plug in your dealio with your entire setup with the boot button held down, or if there's nothing on it, you're just going to plug it in with a USB cable. It should just show up as like a flash drive device, and then just drag and drop the UF2 file over. So let me just open up my file browser here. Go to code, QMK firmware, and that should just be dumped right here. Dual secure, there we go. That's what we're looking for. So probably want to open up another one as well. Swap you guys around here. Okay. Let's see here. So if all is well and good, I should just be able to plug this in and see it as a U.2.
Why must I be tortured again by all this?
And made into cigarettes. There is so much we can learn in the universe.
Testing. Okay, yeah, looks like that might have just caused my USB hub to have a small freak out, but we're back and I'm talking. Can everybody hear me okay? Thumbs up in chat. Oh, cool. I'm good. Okay. All right. So as you can see, it's working great. I am not vibing with whatever this is. There we go. That's a little bit better. So yeah, this side's working perfectly fine here, or at least it looks like it. I'm going to get the other one plugged in and see what I can do there. Might lose my voice again. Maybe, maybe not. I am going to have to partially disassemble this though, because I need to be able to get to the boot button, because these actually have a program already installed on them. So the RP2040s just blink a light to confirm that they're online, whereas like a Pico fresh from the factory is just going to default to going to the bootloader mode in comparison to the RP2040 that's already got a program on it. So let's see, can I see that? Yeah, actually, cool. All I gotta do is remove that, and I've got access to the boot button. I'm just gonna unplug you. So at that point, all I would have to do is hold down that boot button. And then I might be lost on voice here momentarily, but we'll find out here in a second. Well, looks like I'm still here. Alright, gonna share my screen again. Nope, it did not stick in boot mode. 1 second. Okay, it's open. Drag and drop the UF2 over, copy here. Give it a second, and may need to be reset here. There we go, and it's alive. Let's get the VIK module back on. Uh-oh, lost a screw. Come back here, bud. Ah, lost it again. You know, it'd be a little easier if I could just take the top off of this, and so I have a better angle of attack. There we go. A little bit better there. I do feel like I do need to make some adjustments to this adapter plate because I think the holes for actually putting the VIK on are a little bit too loose. It could probably be tightened up a little bit so that threads can be cut through. And then this one's just too thin anyway. That one doesn't want anything in it. So okay, so both sides are presumably soldered up and working correctly. So at this point, all I really got to do is make sure I don't rip that out. Connect the two USB-C ports. Which will be the outer. Okay, and then let's take and plug it in. Hopefully you don't lose me. And there we go. Both sides are online. Let's see if I can type. Going to go back to my desktop. Well, actually, let me get something pulled up here first. I'm gonna pull up. Just gonna do the basic keyboard checker test. share my screen real quick. There we go. All right, so it looks like I was able to type that at least, so escape. 1 is not working, 2 is not. Oh, nope, it was just lagging. 2, 3, 4, 5, 6. Oh yeah, Chrome likes to lag for some reason. Mayhaps this is better suited for Firefox. Oh wait, okay, so I gotta actually do Hyper. Yes, okay. Hyper A, and then we can just do Firefox. I don't know why Chrome is so laggy on Linux lately. It's kind of weird, but whatever. I digress. Actually, probably a better idea to just do via... Oh wait, it doesn't work in Firefox. Okay, never mind. We'll just do keyboard checker for right now. I'll struggle through setting up via later. It's not a big deal. Okay, here we go. Let's just hit Control and make this a little bit bigger here. All right, so let's just go through testing most of these keys. Escape, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, backspace. Let's see, yep, that's good. P-O, yep, T, tab. This is going to be for adjusting RGB modes. So that's not going to show up on this since that's a layer dependent thing. Okay, and then A, S, D, N, G, H. Yep. Enter, question mark, and plus, minus, brackets, tilde, delete, shift, control, that's going to be Windows, menu, oh, and that's volume. So, music may have just gotten a little too loud here. No, I think that's just my actual volume, so that wouldn't matter to you guys. X, C, B, space, enter, space. Oh, this is left and right click. Okay, that means, oh yeah, and there we go. I have a trackball. So, click, that's, okay, never mind. I don't have those buttons set up yet. Okay, cool. Every key works. Let's see. That's volume. This is scroll. Okay. This should also be scroll. Yep. All right, cool. And then last but not least, I need to set up via here. So I'll stop sharing my screen because I've got to go into Discord to download something real quick. Let's go to Discord. This may be a little funky because this is Linux. Bit. Okay, gonna share my screen again here. So with VIA, the way that gets set up is going to go to settings, got the design tab, you'd be turning that on. Sorry, Chrome is just not working well here. So at that point you would click load, and then from the Discord you'd grab the ZodiarkPi.json file. Right here, got it right there. Just click that guy. And then at that point, you'll have a key tester and everything. You should just be able to click authorize device, click that and connect. And as you can see, there we go. We've got VIA support now. So at this point, I can take this momentary one and I'm gonna change that over here. I'm gonna change this to my hyper key. Just because I use Hyperlens, so I need that key there. Yeah, and there we go. At that point, we should just be able to that's very loud, I'm sure. So I'm not gonna bother with that. But yeah, that's how you get VIA working and changing things. I will hopefully be able to get it in there. Just a heads up, these are the encoders. I haven't figured out how to move these from my original info.json file. Other cool thing is that I got lighting working as well, so you can kind of go down here to this right here. That's macros, and there we go, lighting. And you can change all the lighting effects in here too. So, yeah, that pretty much wraps it up. This was a pretty nice build. The only problem that I ran into is I couldn't get the RGB connector on pin on the VIK connector on this side. Works perfectly fine on that side, so not sure on that one. But it is up, it's running, and it is completely functional. So I think that wraps everything up. Let me go back to the webcam here. I guess before I take off, does anybody have any questions? Or I'll do a small Q&A if anybody's actually paying attention to the chat here. And we'll take a quick break while people possibly type. Let's see here, I'll type in chat. And I will be right back. Mute real quick.
You can read in bed with the lights out, or even under the covers if it gets cold.
Okay, well, it looks like everybody's pretty much good to go here. So that concludes the build stream for the ZodiarkPi. Hopefully, I'll be able to work with a friend of mine to get this all chopped up and actually put into a real guide. So, but yeah, I think we are I think we're good to go on this one. Feel free to ask any questions in the Discord, but yeah, this concludes a successful build of the ZodiarkPi. Later, everybody.